This is a strategic review for symmetrical components. Upfront in the course in section number 2, when we encounter symmetrical components, the approach I take is a little bit more general, right? I go back in theory a little bit and explain you what is the need for symmetrical components. The need for symmetrical components stems from the fact that if you're dealing with unbalanced system, three-phase system, where the magnitudes are not lining up, the phase differences are not 120 degrees, your typical equations will not work directly, right? So what we do is that we take unbalanced systems. So this is the example that I used, right? This is my phase A. As you can see that in length, it's less than phase B, and this is phase C, and these guys don't have 120-degree phase shift between them. So what we do is that we are able to convert them into 3 sets of balanced phasors. One is a positive sequence, the other one is a negative sequence, and the third one is a zero sequence. And the beauty of the three-phase system, when it's resolved into symmetrical components, even if it's unbalanced, is that when these guys collectively add up, so if I pay attention to phase A, for example, I take the positive sequence of phase A, the negative sequence of phase A, and the zero sequence of phase A. I combine all of them with the head-to-tail rule, vector analysis. This is FE Electrical, going back a few months. If you took the exam recently, head-to-tail rule, and you are able to recover your good old phase A, right? Magically. These guys are balanced, but this guy was unbalanced, right? And the same concept can be applied for phase B and phase C, all right? So what is going on over here? Very simple, straightforward. You're using symmetrical components to systematically analyze unbalanced systems, okay? From a mathematical standpoint, these equations that are given in a matrix format are crucial, okay, for us to deal with symmetrical components. And as I mentioned, in section 2, when we encounter symmetrical components, I keep it a little bit high level, I keep it a little bit mechanical, a little bit mathematical, right? The real application piece of symmetrical components is going to show up a little bit later in section number 4 when we are dealing with fault analysis. And that's where you are going to start using this as prerequisite information. So if I give you a system that contains the symmetrical components and I'm asking you for phasor quantities, right? You're going to use this first matrix. If I ask you, if I give you the phase quantities and ask you for the symmetrical components, you're going to use this matrix. And the matrix is pretty simple. A is nothing but basically a unit of 1, and then 120 degrees. So A squared basically becomes 1, 120.1, 120. So the angles are going to add up, and this will give us a 240-degree twist. Okay, so that's the relationship, and we went through multiple practice problems in the on-demand, in the quizzes, in the lecture, live training, homework assignments, study guide problem sets. So make sure you get your hands dirty by working through a lot of these practice problems. And the final point I'm going to mention, as we discussed earlier, is that let's say we start out with a positive sequence network, which is a ABC. If this positive sequence network is present, then I only expect to see, in terms of symmetrical components, this guy present, or subscript 1, okay? If it is balanced, then these two should not exist, okay? Conversely, if we are in Texas, we're dealing with the ACB sequence, and we are dealing with a balanced system, then I only expect the negative sequence to show up, okay? If I do the calculation using the matrix transformation, these two should not exist, okay? And an extrapolation of this concept is that on whichever network, whatever network I'm dealing with, if 3 symmetrical component quantities are present, then this is a proof that the given system is unbalanced, okay? So this is a bird's eye view of symmetrical components. There's obviously more to it. And especially when you get to section number 4 and start doing fault analysis, everything starts coming together. And make sure you give it the due attention, respect that it deserves, and put in the time and effort to actually walk through these equations and do some practice problems. Because just by staring at them and thinking that, okay, I'm going to punch this in the calculator, in the matrix, and figure it out during the exam, you know, if you don't have that muscle memory, it can come and haunt you on the exam. So please make use of all the practice problems in the quizzes, in the on-demand content, the study guide problem sets, homework assignments, and so on. Okay. If you're new to this channel, please consider subscribing. On a weekly basis, I'm creating content for FE Electrical and PE Power exam preparation. I also discuss topics related to electrical engineering with a focus on power systems engineering. If you'd like to learn more about my FE Electrical and PE Power exam preparation programs, please visit my website, StudyforFE.com.